With GitHub Copilot, you can shift your development tasks from sequential to simultaneous with the agent of your choice in Agent HQ. The Agents tab on GitHub is where you can manage all your Cloud agent sessions. From here, you can assign ad hoc tasks to Copilot, to Claude by Anthropic, to Codex, or to a custom agent. We can also use this tool to monitor our tasks, all from one centralized location on GitHub. Now, most change requests come via issues, and you can assign issues directly to an agent like Copilot, Codex, or Claude. Choose the branch you wish to use as the base, and again the agent you want, and let the agent do the rest. Inspiration can strike from anywhere, including away from your desktop. We can manage agents and even assign tasks right from GitHub Mobile. Given that developers spend the bulk of their time in an IDE, it's natural to expect to have access to the same functionality from there. In VS Code, you can orchestrate all your agent sessions, local and cloud, from your IDE. Just like before, we can assign to Claude or Codex or to Copilot using a custom agent or specified model. These tools allow you to assign and manage parallel coding agent sessions all within your existing workflow.
Did you know that GitHub has a changelog? We release updates every single day, sometimes multiple times a day, most times multiple times a day, and you can find it at github.blog/changelog.
There's an AI agent in your terminal now.
And we're going to see what it's really capable of.
This is Copilot CLI for Beginners, a series where we walk through GitHub Copilot CLI step by step and explain what it can do.
We'll tour the core features, show you how to use them in real workflows, and break everything down in plain English, from building features to reviewing code and working in the cloud.
You'll see how to actually use Copilot CLI in real dev workflows, all from your terminal.
So if you've ever been curious about Copilot CLI, this is the place to start.
Hello, welcome to Open Source Friday, the show where we talk to maintainers about the apps that they're maintaining. I'm Kidesha, and I'm so glad that you're here with me today. That was quite the dramatic entrance. I chose the most dramatic song for that portion of the pre-roll. But welcome to Open Source Fridays. So happy that you're here with me. We have an incredible guest here to tell us all about his projects. But I'd love to know, where are you joining from? How's your day going? What are you doing? I'm here in Chicago, and it is windy, y'all. Like, it is so windy today. It's actually crazy. But let's get right into the stream. So I'm going to bring up Carlos, who is our guest for today.
Hi.
Hey,
Hi.
Carlos.
Hi, happy to be here.
Yeah, how are you doing?
Oh, good, thank you. And not so windy as Chicago, but doing good.
Yeah, I mean, I woke up and I heard whoosh, whoosh. And I was like, whoa, that is quite the wind. But let's get right into the stream, because when we're having fun, time just goes and goes and goes. So tell us about yourself. Who is Carlos? What do you do? And how did you get into open source?
Of course. Well, as you already said, my name is Carlos. I'm currently, I'm currently working in Node.js Octa, and I gotta say that I'm just another developer that likes to create things, have fun creating things, and also give back to the community through open source. And I gotta say that what bring me to the open source community was that that culture of that warm culture of the community where you can learn, get to know a lot of people, really smart people down the path, to get the opportunity to contribute to something really bigger that is used by basically everyone most of the time. And so, yeah, that's my short story.
Nice, nice. Well, welcome, welcome. Happy to have you. So tell us the story of Piscina. Is that how you pronounce it? Am I pronouncing it right?
Yeah, yeah. It's in Italian, and also in Spanish is the word for pool. Basically,
Oh,
that's why.
nice.
That's
Very
yes.
clever. Very
Yeah.
clever.
So
Piscina. Yeah.
yeah.
So, like, what problem were you trying to solve when Piscina was created, and how did that kind of come about?
Yeah, so I gotta say that first of all, this wasn't authored originally by. If you are active in the JavaScript community, especially in the Node community, you will know maybe about James Snell and Hensen, and also Matteo Colina, among more people. So they are the original authors of Piscina. I had the opportunity to, of course, follow them when they created this really nice library. When also worker threads, implementation for threads in Node get to land. So of course, this came made with the need for having a way to, let's say, more idiomatic and easier way to manage worker pools or thread pools, sorry. And the solution is basically that bring you a really nice and easier to use API that you can start using to distribute your workload across a thread pool. And easy as that, saving you a little bit of time, saving you lines of code, and as well bringing you as much performance as possible.
Nice. And when would someone reach for Piscina over async await? And why would they?
They're a bit different things because worker threads are essentially the way that you manage, or let's say the way that you model threads in JavaScript. So you will use Piscina for example, where you have the common one, you have a heavy CPU task. I don't know, you are streaming data. You maybe need to render, for example, do server-side rendering on some of the stuff. And that's when Piscina comes into play. So you, instead of keeping your main thread event loop busy, you can leverage all the workloads to Piscina and create many work threads as your application allows you, as your server allows you, and start using it and increase the performance of whatever workload you're doing. So this is the use case. I think a way this is a little bit different, but yeah, in a brief, that's how it helps.
Nice. So I guess let's take a look at it. I know you have a demo for us today.
Of course. So yeah, this is the demo for today. So I'm showing you right now. It's a small new project that I just built in. So to give you an idea of what Piscina does. So let's say that you wanna, as I said, you wanna create maybe a small worker thread pool because maybe you wanna, I don't know. Sorry, Copilot wanted to join. So let me just also another file. So I don't know, you want to do something really heavy and leverage, I don't know, rendering an HTML for a server-side rendering, or maybe doing some compression of your image, you name it.
Yeah, I was gonna say image stuff is always heavy.
Yeah, so imagine that you are not using Piscina, so I really prepare a small snippet here. This is the lines of code that you will need to use, right? You will need to, of course, import worker threads. You will need to do quite a few magic, and you will need to manage all the worker-related communication between your worker and your main thread, right? So you'll need to get ready and say, okay, this is my message. In this case, what I'm doing is super simple. It's just we're sending a message and we are saying if the number is pair or not. And you need to orchestrate basically all the information between your main thread, which is in the index.ts, and of course, your worker, which I already prepared also another snippet right here. So as you can see, you receive the message. We're going to start from the index. You receive the message. Sorry, this is not the one. It's right here. Yeah. You create your worker right here, and you say, okay, this is the file to the worker, which is located right in this file. And you're going to start, of course, receiving messages from your worker and this is your thread. And you're going to start also listening to some other pieces of your code. Sorry, I forgot to print one more piece of code. And yeah, so when your worker is ready, you do your first initialization, your worker is ready. So what you're going to be doing is, of course, sending the command spare. And yeah, on the other side, your worker will receive it. I will say, oh, okay, I get a new message. This is the message that I'm receiving. I'm going to be checking, okay, if it's pair. I'm going to do a small calculation just to see if it's truly a pair. And I say, yeah, this pair is true. And I will return it back. So if I run this piece, let's do it, node.index.js, you will see exactly this. Your your main thread is sending, okay, number 2 is pair, number 4 is pair, number 6 is pair, and so on and so forth. And the worker itself is also telling you, oh, okay, from the parent, I receive a specific command called isPair, and the data is 2, 3, of course, I'm returning that, yeah, 2 is pair, 3 is not, so I'm not returning it to the main thread, and so on and so forth. Really simple. And to save all those lines and to also give you the benefit of more performance in the communication with your worker thread and so on, that's when Piscina comes in. So with Piscina, we're going to save all these lines of code, of course, first of all this burden of communicating or orchestrating your worker communication into just a few lines, just like this. And instead of those previous 45 lines, you just now have 28 lines where you have just importing Piscina. You tell to Piscina, this is, oh, compiler is still now suggesting. Piscina, this is what is your worker file, which is the one that is right here. How many threads do I want? What are the maximum number of threads? If I want to use atomic, which for the purpose of this part is not really important. You want to have a custom load balancer and so on and so forth. And what we're going to be doing is, of course, just doing a small for loop. I'm going to be sending the numbers from 1 to, from 1 to 10. And we're going to be receiving the payload, and we're going to be printing it into the console. On the other side, from the worker, instead of having you to deal with receiving through the parent port and handling all this messaging, instead of that, you just need to export your function just like this, handler. You're going to receive the command, you're going to receive the data, and you can do exactly the same thing that we did, calculate. You're going to say if it's pair or not. And easy as that. Easy as that. And this one here is going to comment it because it's going to put a lot of noise. So if I run it, just in the same way, let me just clear out everything, just in the same way. You're going to see that we are exactly doing the same as we were doing in the previous demo, but of course, without having to deal with the communication and intrinsic, without having to deal with many of their other semantics that are needed. So it saves you a lot of time. It also gives you a lot of benefits. And one of the biggest benefits of this is that, as I said, you can implement your own load balancer. So you can say, I don't know, maybe in this case, what I'm doing is distributing the task across the even workers. So I have just 2 workers, and I'm saying, okay, for one worker, I'm going to send it here. For another worker, I'm going to send it here, depending on the task ID and so on. But you can do many things. You can put a load balancer for, I don't know, having sticky sessions. Let's say that you want task to go to a specific worker all the time because you have a specific setting. You can also do it by yourself. And yeah, easy as that. So of course, this is in JavaScript, but we also have it in TypeScript. That's one of the interesting things that we're working on at Piscina. So I'm going to just create a new file called index.js. And here what I'm going to be doing is, here as you can see, I'm using another version of Piscina, which is Piscina v6, that is coming up later this year. So I just put this as a reminder. And one of the biggest changes that we did is that now, of course, with TypeScript, type inference and everything, you would like to have the benefit of the types and say, okay, what kind of workload I can have. So now with the new Piscina version, we are allowing you to implement these generics. So you can also tell to TypeScript what is the shape of your function that you're exporting, what is returning, what is the payload that they're expecting, and so on. So for example, right here, now I have suggestions saying, okay, if I click on this, I can see that now the IntelliSense is also telling me, okay, you can choose between calculate, you can choose between divide, and it works exactly the same. And on the other side of the spectrum, we have the worker, of course, so worker that yes, which of course we have the calculate and we have the divide. And what we're gonna do is of course use this command now that Node is also capable of running TypeScript code. And you can use this command. I can go right into the boilerplate and just say, okay, just run index.ts. And easy as that, we have printed the numbers 5 and 47 because we are calculating exactly those values. We're summing and we're dividing. So yeah, that's in a brief. And yeah, welcome to Piscina.
Yeah, simple and easy and straightforward. That's awesome. So we have a few folks that just joined. How would you describe what we're talking about? Like, how would you describe Piscina in like one sentence to get people up to speed?
I gotta say, the worker, how can I frame it? The thread pool library for Node. Yeah.
Nice. Love that. And that brings me to my next question. So what's the difference, would you say, between Piscina and Node's built-in worker threads?
I can say that there is no big difference in a way of how it works because at the very end, Piscina is also using worker threads. But the difference roots to the fact that with worker threads, you need to do everything by yourself. You need to know how to orchestrate your workers, how to know when one worker is alive, maybe when one worker is has exit because it had an error or something. And all these problems are abstracted with Piscina. And on top of that, what we're also trying to do is implement some optimization so things can go a little bit faster, as much as, of course, worker threads allow us and some other tricks allow us. But that's the biggest difference. You can see Piscina as an abstraction on top of worker threads.
Got you. So it works along with worker threads, not instead of worker threads. Got you. Exactly. And so like when a developer is just starting to implement Piscina, what would you say is the number one mistake they make when they're starting to work with worker pools?
I gotta say that sometimes, at least also the same mistake that I did is, of course, not having into consideration, not necessarily with Piscina, but with worker pools in overall, is there different failure modes and in different intrinsics of it. When one fails, what do we do? Should we recover? Should we not recover? If you are using, for example, Piscina supports abort signals. So that means that any workload can be aborted. So how do we handle an abortable task? Should we, because you cannot cancel, most of the time you cannot cancel the workload by itself. So what Piscina does is that isolates this task when it's abortable, so it can be completely aborted and closed and cleaned up without side effects to the rest of the workload. So these intrinsics and small issues that comes with managing worker thread pool is something that sometimes is really easier to oversee because they are not predictable all the time. So you need to guess them some of the time. You need to really think ahead of them. What kind of things could go wrong? Because most of the time it can go wrong. So I'll say that this in specific, the failure modes and all these smaller details that are easy to get overseen.
Got you. Sorry about that. Awesome. So I guess like, what are some real examples of applications using Piscina where it made a difference, like where you've seen it made a difference in, I guess, the performance, right? The CPU performance?
It really varies because sometimes, and also that's when where Node.js also shines sometimes, having multi-threading is not necessarily the best option. because they are starving with themselves and trying to monopolize the CPU time being used. But in workloads where it fits is usually in those that have heavy computations that often require you to receive the more traffic as possible or the more requests as possible and try to somehow offload that work to somewhere else. Things like server-side rendering, for example, is a really good use case. If you are doing heavy computations on images or you are doing something heavy on things like data manipulation, maybe that you want to decompose big chunks of data or handle big chunks of data at different times. In these use cases, I have seen a really nice impact. But of course, one thing that I would recommend is to first always assess your workload with the different solutions. It could be by itself, just using Node by itself, or if you want to implement worker threads as well with worker threads, and assess the different outcomes to see which is the best one, which solution is the best one for your problem. Using a thread pool is not always a full solution or a solution to every single problem. So always assess and evaluate and decide what to do based on that.
Nice. That's very good advice. Very, very good advice. I'm not seeing any questions in the comments. I'm just going to keep asking you questions. Is there anything else you want to share about Piscina that you think that we should know?
Well, right now I'm gonna say that there are a few things that are coming up to Piscina. One of them is this new generic, so you can now properly infer the different sets of functions that you have in place, like I just showed. One thing that is also coming up soon is a small optimization in the thread IDs, but it's not really seen. Another really interesting feature that we worked on last year is the load balancer, which is really nice because it allows you to do many different things. The load balancer can be really a really nice feature, a really nice feature to take advantage of, because it will allow you to basically distribute the workload as you wish. So you want to have something in specific, always have your task go to a specific worker, or even balance the worker in a different way. Maybe you want to implement which is the less busy, or which one has more consumption, less consumption, and distribute the workload based on that. You can implement any load balancer algorithm with this. And so this is also really another interesting feature to dig into it. And I'm trying to think one more. And I think those are the most interesting thing coming up, and one of the most interesting thing that we added on last year.
Really like that. Yeah. Okay, so we have some questions. Awesome. So at what point does using worker threads with Piscina become worse than using a separate microservice for CPU heavy tasks?
I gotta say, I gotta use the famous solution word. It depends. Yes, because sometimes, and I gotta say that, and I have to say that it also comes with the nature of microservices, especially in workload and in things like, for example, Kubernetes and all these solutions or container orchestrations. They're most of the time done, not necessarily 100% of the time, but most of the time done in a way that you don't need to really do too much. Well, again, depends. Do much CPU decomposition and using worker threads or using threads for this and this kind of tasks. Sometimes it has more sense to, in this case, use Node and just have more microservices made with Node, or most not made with Node. But in those where there is a limitation of how many pods you want to put outside, or how many replicas can you have, and as well you want to maybe increase the throughput through a single replica because you have an API gateway, or you are doing server-side rendering, for example, which are the most common use cases that comes to my mind. And this is, in this kind of scenarios, is what I would say Piscina is a really nice solution, a really nice go-to. But again, it really depends on what are you doing. And I gotta say that an 80% rule, 80% of the time is better to just keep it as is. And the other 20% of the time is Piscina could be a good fit. It really depends on your workload.
Nice. That's a really good response to this question. So I guess like to follow up on this, if someone tries Piscina and they don't see any speed up or improvements, what do you think are the top like two most likely reasons? Did they just not implement it properly?
It's possible, but at the same time, it's also possible that at a hardware level, it doesn't have too much sense. It's really, as I said, sometimes when you have too many threads, they're just starving between each other because they are just competing to see who can have CPU time to run the workload. So often in you're facing these situations, it really means that maybe having multi-threading is just hurting you more than is benefiting you. So that's when I root back to my previous advice of try different combinations. Try, if you're using Node, try Node by itself with a single thread. Try it with Piscina and try different combinations with Piscina. And even if you want to go ahead and try with worker threads alone, try with worker threads alone, but always experiment, get the results, and assess and see which one has the more benefits for your problem.
Yeah, nice. And this question, what is the real-time application of Piscina? So like what app types or what's the most applicable, what applications need Piscina essentially, I think is what they're asking.
I'm gonna say that ones that really has CPU bonding problems where they can, in this case of Node, of course, block the event loop. Things that I can think of are, I've been using it quite often. Server-side rendering is one of them. Sometimes data processing. Maybe you want to split a big data size and you want to split it into smaller chunks. If your workload is really prone and you're seeing problems of event loop lag, really long event loop lag and event loop blockage in your application, Piscina could be a really good solution. But as I said, going back into what I said already, I'm going to use it quite often. Always assess different solutions and see which one fits the better.
Nice. Love that. And one more question I think I saw here. So for CPU-heavy workloads, is Piscina generally preferred over Node's built-in worker threads, or is it more about easier pool management?
I gotta say that in this case, it's more about easier pool management. Yeah. If you find yourself having a specific use case where Piscina doesn't fit, of course, going right into worker threads API will be way better. Because maybe you want to do some optimization that Piscina doesn't do, or there is a problem that Piscina cannot really help you, then of course worker threads would be a best option. But it's mostly easier management. We have also some optimization for performance, but of course it's not a replacement for worker threads. At the very end, we also use worker threads.
Nice. And last question here is, how does Piscina manage task scheduling and thread pooling?
In this case, it depends on your settings. By default, it's going to use, at least for thread pooling, it's going to try to create as much threads as the OS allows us by using the number that libUB gives to us. I think it's, and remember the API, max concurrency. And based on that, we're going to create the threads. And the task scheduling, at least the default one, we use the least busy, meaning that the one that doesn't have, the first one that doesn't have too many tasks is the one that is going to be picked. We have also some built-in balancers, if I'm not wrong. Let me see if I have some balancers in place, because I remember the names. Yeah. We have, well, this is how the task use. But no, by default, the task scheduling we use is the least busy one. And we use a normal task queue, which we just start. I know we use a fixed array task queue, which we also
Mm-hmm.
get inspiration from Nodes one for enqueuing the task. But yeah, I gotta say that that's the default for Piscina. Of course, you can customize it as you want by the load balancer, by adding your own task queue. It's completely
Mm-hmm.
customizable, but by default are these ones.
Cool, cool. And how do you manage error handling here? Do you get like stack
Uh,
traces for stuff?
Yes, we of course communicate the error. I mean, what it happens is that if the worker fails, it's gonna also send this error information back to the main thread. And on the main thread, as we can see here in this case, the run will
Mm-hmm.
always return your promise. Whenever you want to catch it, you're gonna have an error printed here with the traces, what went wrong, what is the message, and so on and so forth. So this is how it works. Usually when it fails, and depending on the settings as well, it's going to tear down the thread and try to spin up a new one if the min threads is slow, or depending on your settings as well.
Cool beans. Anything else you want the folks to know about Piscina, or are you looking for contributors on GitHub?
Yeah,
What
it
would
would
you
be
like
nice.
folks
I
to know?
mean, it will be super nice if you are if you are really interested into Piscina. You wanna there is an issue that you wanna fix in, or there is a feature that
Mm-hmm.
you would like to see in Piscina. You're willing to contribute. We're looking for contributors, of course. Any contribution, any bug report, any support is really welcome. And yeah, anytime you have my handle. If you need something more information, you wanna have a chat
Mm-hmm.
around Piscina, feel free to reach out.
Yeah, and I know you had something else you wanted to share your talk on untangling threads. You want
Oh
to tell us more
yes,
about
yes.
that?
Yeah, that's a small talk that I did last year, where exactly everything that I have explaining to you here in during this time, I also explained it in this small talk. So you can also have the chance to look at it. You're more curious about Piscina, about what some other things that I thought there were implemented last year. Some others like iterator support
Uh-huh.
is still in the works, which iterator support is one of the features that I'm really more interested about and most excited about. I've been having a little bit of troubles implementing them because of time, but that's one of the features that I'm really looking forward to land. And yeah, please, so you have anything that you would like to add on the presentation, on the small talk that I did, feel free to also, any feedback is welcome. And yeah, I think that's
Yeah.
mostly it.
Because I'm looking at the presentation here. If you want to pull it up just so folks can see. And you
One
were pretty
second.
much going into what is a thread and how does and like bringing it back to Piscina and how it relates. So for those who are unfamiliar, what is a thread and how does it relate to Piscina? I know we've been talking
Okay.
about it.
Yeah, sorry, I was looking for I was looking for the presentation. Yeah, I gotta say that a thread is a smaller set of instruction, or a small set of instruction that you can use that can be executed by your CPU, and you can see it as it's not necessarily as a process, because as a process is a concept per se, but you can see yeah, like a small one of the minimum small chunks of instructions, yeah, as I said, that your CPU can run. It shares a space yeah, memory space with the parent, in this case, who instantiated the thread, and it's really good for CPU bound workloads. As I said, server-side rendering, really computation, you name it.
Awesome. Well, this was a really good chat. Someone is asking you, as a core maintainer of Piscina, what are the biggest mistake beginners make when contributing to open source?
Because I've been also doing that mistake, is honestly being afraid to ask. Don't be afraid to ask. I remember when I was doing my first contributions years ago, I was really shy to give it a try, because I was afraid of doing a bad contribution, or not doing it good enough. I don't know. But the truth is that most of the maintainers are gonna welcome your contribution, of course, when you are doing it in a really good will, when you are really trying to help the project and trying to also be part of the community. So don't be afraid to ask. Don't be afraid to submit and go for a task. If you see a issue, could be documentation, a typo, could be a small bug that you know you can fix it. Just go for it. Honestly, that's the best way that you can engage with the maintainers. Just go, open your PR. If you have questions, feel free to ask them in the issue. Feel free to also ask them in the pull request. And maintainers most of the time, I gotta say that my vast majority experience when doing the contributions, they are really willing to help you. So that's my advice. Don't be afraid to ask, and feel free to go for it.
Love that. And definitely go check out Piscina. I know I saw in the repository there are a few open issues that you can, take a look at and just like go and play around in the code base and see how it's built, how they're managing, all the wonderful things that they're doing. And Carlos, thank you so much for coming on to Open Source Friday today and showing us all about thread pool, worker management, all the things. It's been really fun hanging with you. And any last words before we wrap up here?
I just want to thank you for everything. Thank you for the time. Thank you for the space. And you know how to reach me out if you have any questions. Again, thanks a lot. Thanks a lot for your questions as well. And looking forward to see your contributions.
Yeah. And Gabrielle says, what does open source entail? Take it away, Carlos. How would you answer this question?
I gotta say engagement into the project. When you engage into the project, you start liking it. In my case, I really engage with the different projects that I contribute. Piscina, where we're talking about, Undici as well, Fastify, the HTTP framework. And it really entails getting engaged with the maintainers and getting engaged with the community. And always be open to suggestions, to feedback, to contributions in this case. But it entails engagement at the very end.
I agree. And I think like one of the core things I love about open source is the belief that everyone deserves free and open access to software. I really love that you can find an open source project that you can use freely on almost anything, which I love. Yeah.
Yes. And that's what makes it fun, because most of the time it's people that also like what you like, and together you can be building something really nice.
Exactly. Well, thanks so much, Carlos. And thanks so much, everyone, for joining us for Open Source Friday. And I think that's all we have for you today, folks. See you next time. Bye.
See you.